The purpose of this video is to find the derivative of inverse functions, and I want to start with just simply reviewing what are inverse functions. This is a concept that you should have encountered in Algebra 2 and then looked at again in pre-calculus, and of course we just recently found the derivative of inverse functions. So as you can see from the notes on the screen, a function g of x is said to be the inverse of the function f of x if f of g of x is equal to g of f of x, and they both equal to x. In other words, the functions undo each other and you get right back where you started from. This means that the domain of f is the range of g, and the domain of g is the range of f. In other words, for two functions to be inverses of each other, the domain of one is the range of the other, and vice versa. The domain and range simply switch places. So, for example, a vertical asymptote on the original function f would become a horizontal asymptote of its inverse function g, and likewise in reverse. So another way to think about this is if you have the point f of a equal to b, then on the inverse function, g of b would equal to a. Notice that the x and y switch places. Another way to simply look at this is when you, let's undo that. Let's grab a pen here. Alright, so in other words, another way to look at that is that if you have the point AB on the original function f, then you'd have the reverse point BA on its inverse. So when does that happen? Well, a function only has an inverse function if it is 1 to 1, meaning that it passes the horizontal line test. So, for example, if we have a parabola has an inverse, but the inverse is not a function because it doesn't pass the horizontal line test. There's an inverse relation, but there's not an inverse function. So again, we use the horizontal line test to determine whether a function actually has an inverse function. Hopefully you've already taken a few minutes to work on this problem. We have the function x cubed, and so I asked you to sketch that function, which is a pretty basic function, and then I asked you to find the inverse of that function. So if we were going to do that, first of all, I would take y equal to x cubed. Notice I just replaced f of x with y. The way that we find an inverse function is that the x and y's switch places, so we get x equal to y cubed. And then the third step of that process is to solve for y. So y is equal to the cube root of x, which could be written as f inverse is equal to x to the 1/3 power. And I said to name it g, so it would be g of x is equal to x to the 1/3 power. And if I were to find f of g of x, or g of f of x, I would get x. In other words, I would get right back where I started from. So the next thing that I asked you to do was to sketch both of these functions on a graph. And so hopefully you did that. Whoops. Get my pointer back here. So hopefully you sketched the original function and its inverse. You'll notice that on my graph, the original function y equal to x cubed is sketched in blue, and on the inverse function, g is sketched in red. And I've selected a particular point on the blue function. If you'll take a look at the blue function, I've randomly selected, well, it's not random, but I selected a point 2, 8. And so on the inverse function, his partner point is the point 8, 2. Now hopefully you're recalling another characteristic of inverse functions is that they reflect over the line y equal to x, which is why I've dotted that line in there. Alright, number 3, we've already sketched those graphs. Number 4 asks us to find the derivative of f, the original function. So if we find the derivative of f, we will get 3x squared. And then it asks us to find the derivative of g. Let's do that in red. The derivative of the inverse function would be 1/3 x to the negative 2/3, because 1/3 minus 3/3 gives us negative 2/3 by the power rule. All right, the next thing that we've been asked to do is now to actually find the derivative of f at 2. Remember, we had on f we had the point 2,8, and on the inverse function we had the point 8,2. These are partner points. It's very important that you understand this relationship between the partner points to be able to find the derivative. All right, so if we find f prime of 2, we're going to substitute 2 into f's derivative, which would give me 2 squared is 4 times 3 is 12. If I find the derivative of the inverse function, g, at 8, I'm going to substitute 8 in here, and I'll have 1/3 of 8 to the negative 2/3 power, which is the same thing as 1/3 of 1 over 8 to the 2/3 power, because we have a negative power, which is 1/3 of 1 over the cube root of 8 squared. We know that the cube root of 8 is 2, and 2 squared is 4, so we have 1/3 times 1/4, which is equal to 1/12. So at least at these two particular points that I've chosen, these partner points, you notice that the derivatives are reciprocals of each other. And that's pretty much the key to your success on finding the derivative of inverse functions, is understanding that partner points on inverse functions have reciprocal slopes. Let me say that again, because that's important for you to write down. Partner points on inverse functions have reciprocal slopes. So another way to state that is let f and g be inverse functions. And again, I'm proving that they're inverse functions by saying f of g of x is equal to x, and g of f of x is equal to x. Hopefully you remember from algebra that that's a way to prove that two functions are inverses of each other. And then f of a is equal to b, and g of b is equal to a. In other words, these two are partner points. On f we have the point AB, and on g we have the point BA. And that's just how inverse functions work. The derivative, as we just discovered, symbolically says if AB is the partner point to BA on inverse functions, again, we're stating that they will have reciprocal slopes. So the derivative of the inverse at B is equal to 1 over the derivative of the original function at A. So there's that reciprocal relationship. Another way of stating that is that if G is the inverse of X, then G inverse, oh, I didn't get my pen again, then G inverse is equal to 1 over the derivative, the derivative of G is 1 over the derivative of F of G of X. Now, just looking at this symbolically can seem a little bit confusing, and obviously we're going to do some examples here in just a second. But I want to show you where this formula comes from. If we take the fact that f of g of x is equal to x, remember that's a property of inverse functions. You get back where you started from. So in this case, we're saying that g is the inverse of f. So I'm going to find the derivative of both sides. On the right-hand side, finding the derivative of x is very easy. The derivative of x is simply 1. On the left-hand side, I'm going to use the chain rule to find the derivative. So I'll find the derivative of the outside, which will give me f prime of g of x, multiplied by the derivative of the inside. The inside is g of x, so I get g prime of x. Therefore, if I want to find the derivative of g prime of x, which is the inverse, it's equal to 1 over the derivative of the original function of g of x. So that's where that formula comes from. It's not just random. All right, so again, what's the big idea here? Well, the big idea is inverse functions at corresponding points have reciprocal slopes. That's the big idea. Notice I wrote it 3 times. Inverse functions at corresponding points have reciprocal slopes. One more time. Inverse functions at corresponding points have reciprocal slopes. Again, that's going to be the key to your success. That's what you want to say over and over and over to yourself. This can get confusing, so let's look at a few examples and see how this works. Okay. All right, so here we have a couple of problems. Problem number 1 gives you a function, and it says to find the derivative of f inverse at x equal to 2 by, so it's asking us to do this 2 different ways. First of all, it's telling us actually find f inverse, find his derivative, and substitute the value of 2. So let's start with part A. So let's find f inverse. So I'm going to have y equal to this, whoops, get the eraser here. All right, so I'm going to have y equal to the square root of x minus 4. I'm going to switch x and y, so I have x equal to the square root of y minus 4. Remember, that's how you find an inverse. That'll give me x squared is equal to y minus 4, squaring both sides. So y is equal to x squared plus 4. That is the inverse function. That is f inverse. So I actually found the inverse. F of x is equal to x squared plus 4. All right, now I'm going to find the derivative of that. Some funky notations here. So the derivative of the inverse is equal to simply 2x. So if I want the derivative of the inverse at 2 times 2 is 4. So that's one way to actually find the derivative at a particular value. Actually create the inverse, find the derivative normally, and substitute in the value that you're looking for. All right, now let's take a look at another way of finding the inverse. Another way of finding the inverse that I think tends to be a little bit easier, I like to make a chart, and in my chart, on one side I have the original function f, and on the other side I'm going to talk about f inverse. So notice in this problem we are finding, this is very important, we're finding the derivative of the inverse at x equal to 2. So this x value, 2, is an x value on the inverse, meaning that on the original function the 2 is a y value. Remember, the x and y's switch places. So I'm going to actually find the corresponding x value that goes with 2 using the original function. In other words, I'm going to substitute 2 in place of f of x equal to the square root of x minus 4. Square both sides and I get 4 equal to x minus 4. Add 4 to both sides and x is equal to 8. So on the original function, when y is 2, x is 8. Meaning that on the inverse, when x is 2, y is 8. Remember, the x and y's switch places. Okay, the next thing that I'm going to do is I'm actually going to find the derivative of f. Now all this does is it prevents me from having to actually find the inverse function and then find the derivative. So I'm going to find the derivative of the original function f. To do that, I have the original function is, look up at the top, x minus 4 to the 1/2 power. So I'll have 1/2 of x minus 4 to the negative 1/2 power. I'm going to find the derivative at 8, because remember, I'm finding the derivative at an x value. The derivative at 8 would be 1/2 of 8 minus 4 to the negative 1/2 power, which is 1/2 times 8 minus 4 is 4. And since I have a negative 1/2 power, I have 1 over the square root of 4, which is 1/2 times 1/2, which is a fourth. So the derivative of 8 on the original function is 1/4. Therefore, the derivative of his partner point on the inverse function, remember what we said, partner points on inverse functions have reciprocal slopes, so the derivative is 4. And so either way that I do that problem, I get a derivative of 4 at the point 2,8 on the inverse function. Now remember, you can watch this video over again and play it at your own pace, but it's going to take a while to just kind of let this settle in and think about it. Alright, let's take a look at problem number 2. I've been told in problem number 2 that g inverse is the derivative of g. I'm to write the equation of a line, so as soon as I read that, write the equation of a line, I'm going to go ahead and remind myself y minus y1 is equal to m times x minus x1. That's my ultimate goal. The line that we're looking for is tangent to the inverse function. Alright, so when I find slope, I need slope of the inverse function, and the x value that they're giving me here is x equal to 2. So again, I'm going to make that little chart. I think you're going to find this chart very helpful. This is g. This is g inverse. Now notice in this problem, or in the chart, they don't give me any information whatsoever about g inverse. Secondly, notice that all of the information about f is simply extraneous information, because nowhere in this problem do they connect g and f. In fact, they say in this problem the name of g's inverse is g inverse. They don't have any connection to f here, so that's just extra information. The x value, x equal to 2, that's an x value on the inverse function. So I have an x value of 2 and a y value I don't currently know, but I'm going to need that y value to write the equation of the line. On the original function g, even though I don't know what either of these functions is, I have information in the table. So 2 is a y value on the original function. My chart does have information about g, and notice in the chart, when 2 is a y value on g, the x value is 1. So that tells me that on the inverse function, if on the original function I have the point 1, 2, on the inverse function I have the point 2, 1. Alright, so far then I can go ahead and write my equation. Y minus 1 is equal to m, which I don't currently know, times x minus 2. So it's clear to me now that the only thing that I need is the slope. Well, this is my slope row. And remember, partner points or corresponding points on inverse functions have reciprocal slopes. So if I can find the slope of this point, 1, 2, on g, then I know that the slope of g inverse will be the reciprocal of that. Well, if I go back in my chart and I look at x equal to 1, and I go over to the derivative of 1 on the original function is 5. Again, remember, corresponding points on inverse functions have reciprocal slopes, so the slope on the inverse at 2 is 1/5. So now I can write the equation of my line, y minus y1 is equal to 1/5 times x minus 2. So it's really kind of like a little puzzle where you have to really take your time and think through the problems. Alright, let's look at one more example, and then I'm going to give you some to do. Problem number 3. M of n of x is equal to x, and n of m of x is equal to x. In other words, they've simply just told us that m and n are inverse functions. That's the first thing that we've established. They've also told me, all right, here we go making our chart again. Here's m, here's n. They've told me on m I have a 0.5, -9. They've told me that the derivative of 5, or the slope at 5 on the original function, is -8/11. They've asked me to find the derivative of n at -9, so n is the inverse, -9 is the x value, telling me that the partner y value is 5 because the x and y's switch places on inverse functions. And finally, we know that corresponding points on inverse functions have reciprocal slopes. So if the slope at 5 on the original is -8/11, then the slope at -9 on the inverse would be -11/8. Now be careful, the slopes are reciprocals, not opposite reciprocals, but simply reciprocals. In other words, we just flip it. So the derivative at -9 is equal to -11/8. All right, again, review this video as you need be, but at this time I'd like for you to start working on packet page 25B, 25C, and then from the book, problem page 179, number 47, and number 59. Study this very carefully this weekend, and I will see you on Monday.